Hello everyone, I am Dr. N.P. Deepak, Assistant Professor, Department of Mathematics, SNS College of Technology, Coimbatore. Today we are going to see a case study on partial differential equations. Differential equation is nothing but it has a derivative which may occur at any point. There are two types of differential equations, one is ordinary differential equations and partial differential equations. Ordinary differential equation is nothing but it has a single independent variable. Partial differential equation occur means it has two or more independent variables as partial differential equations. Today we are going to see case study on partial differential equations. Partial differential equations have real life applications in mechanical, civils and electrical machines. Here how partial differential equation appear in real life means if you heat one end of a metal rod, what do you think will be appear means the heat
will travel along the rod. That is, the heat travels from higher concentration to lower concentration. So that once hot end of the rod will start cooling and the cold side will get hotter.
This flow of heat is known as heat conduction. We can show the heat as a heat equations in partial differential equations, which is nothing but dou u by dou t is equal to a into dou square u by dou a square. Q is a function of x and t. X is nothing but position and t is a time.
So the change in temperature is with respect to time and it depends on. So how it varies in this case?
Imagine you have a 10 cm metal rod. Here left will be x is equal to 0 is kept at 100 degrees Celsius. Then right hand will be x at 10 cm is at 0 degrees Celsius. We can initially the whole rod will be at room temperature is 25 degrees Celsius. Then we can take the boundary condition and initial condition as
u of 0 comma t equal to 100 and u of 10 comma t equal to 0 and u of x equal to z which is equal to 25.
U of 0 comma t, U of 10 comma t and U of x comma t is nothing but initial and boundary conditions, which is conditions to solve the problem. Solving this PDE, which helps us to how the temperature changes with time until the rod reaches equilibrium. Give me the real life applications.
The real life application of PDE, electrical and electronics engineering, electromagnetic fields, Maxwell's equation or PDEs that describe electric and magnetic fields, transmission lines and waveguides, wave equation for signal propagations and semiconductor, PDEs model current flow, heat dissipation and electron diffusion, antenna design and microwave engineering, Helmholtz equation, Bohr's radiation and resonance.
Solving this PDE, which helps us to how the temperature changes with temperature rod reaches equilibrium.
PDE would help to predict the temperature with any time and any distance.
With PDE, we can design things like heat exchange in power plants, cooling systems in electronics, even thermal production in spacecrafts.
Yeah, I'm solving real life engineering problems like in mechanical field, electrical field, and thermal field.
In PDE also describes vibration in bridges, sound waves in acoustics, fluid flow in pipelines, electronic waves in communication systems.
So PDE is nothing but they are like a bridge between maths and engineering life.
Give me some more real life applications.
In mechanical engineering, heat transfer, heat equation models conduction, convection and cooling of machines, vibration of machines, wave equation models vibrations in beams, shafts and plates.
What are the learning outcomes of the partial differential equations?
So as learning outcome for PDE, we learned how to construct equation with respect to time. That is heat transfer of a rod, and also we learned about its application in electrical field and electronics field such as wave propagation and signal transmission.
Give me some real life applications in civil engineering of partial differential equations.
So coming to the real life application of PDE in civil engineering, the main application is structural analysis. That is monitoring or keeping in track of the pillars or the supports beam of bridges and architectural marbles, which ensures to maintain them properly without any degradation in their strength. So other civil engineering application is earthquake engineering. That is, these earthquake waves are similar to the seismic waves. So since PDE depends upon time with respect to time, so these seismic waves can be predicted earlierly with this PD. So another civil engineering application is the groundwater flow, which involves the Laplace equation for underground water and tank safety. So soil mechanics also comes in place, in which PD is used for consolidation and settlement analysis.
Applications in computer engineering.
So the real life applications of computer engineering is like first image detection. So we can use image processing method like OpenCV to reduce the edge detection and noise and reduce the segmentations and the disturbance in the image processing. Second is ML and AI, machine learning and artificial intelligence. PD based optimization in physics informed neural networks. So neural networks acts like a brain, which would connect all the networks which are interconnected, which are interconnected to a server. So we can use PD in that thing, and also we can use in telecommunication based like signal communication, transmission, and all those stuff.